Alright, welcome back to a science problem of the day. Today's problem will be from the area of general chemistry, and what we're looking at is an ibuprofen suspension for infants. And so if you don't have children, or if it's been a while since you've been around any children, or at least children that needed ibuprofen, then you may not quite understand what this is talking about. Normally, children's ibuprofen or Tylenol or, those sorts of things come with or in a suspension where the drug, the medicine, is suspended in some sort of liquid, and usually it's flavored so the kid will enjoy it. And they sell it with a little plastic syringe with a little plastic nub on the end, and you stick that into the bottle and you can suck out the amount you need. So in this case, it's telling us that there is 100 milligrams for every 5 milliliters of this medicine. And if that is true, this is kind of the information we read off of the bottle. We want to know how much should we give to the child. So we weigh the child and we find that the infant is 21 pounds. 21 pounds. And we know also from the back of the bottle that there is 10 milligrams should be administered of the ibuprofen for every kilogram of body weight. So you may say 1 kilogram. So this is 10 milligrams of ibuprofen for every 1 kilogram. And there are 100 milligrams of ibuprofen for every 5 milliliters of the solution. So we're starting out with 21 pounds. Ultimately, what we want to do is convert this to kilograms, because kilograms is mass, and we know how kilograms relates to milligrams of ibuprofen based on this ratio. Now, it's important to remember in these sorts of ratios that you can write them either way. So I could use it as 1 kilogram is 10 milligrams of ibuprofen, and it doesn't matter which one's on top or which one's on bottom. I can use them both ways. The only time it matters is when I need one or the other to cancel out. Then I have to use the ratio in such a way that the one I want to cancel will be on bottom. So notice I'm starting out with 21 pounds, and I want to find a ratio that's going to relate pounds. Notice I put pounds on bottom here, so that way it's multiplying and dividing by the same unit. And it's going to convert these pounds to kilograms. That would be the ultimate goal if possible. So I'll check the back of the book here, which is usually where we find the answers at for these sorts of conversions. And we can see that 1 kilogram relates to 2.20 pounds. So I'm going to say 2.20 pounds in that way. Okay, so if that's true, then we know how many kilograms of body weight this child has. When we do this multiplication, or really it's 21 divided by 2.02, we'll find out how many kilograms the child weighs, or what the mass will be there. And so if we know how many kilograms, we can now have a relationship, or we had one, we can use it here, and we'll put kilograms on bottom. And it tells us 1 kilogram corresponds to 10 milligrams of ibuprofen. So 1 kilogram of body weight of your child needs or requires 10 milligrams of ibuprofen. So notice my kilograms cancels out. Here I'll be left with milligrams of ibuprofen. So let's go ahead and find out what this is equal to. So if you take 21 and you multiply by 10 and you divide by 2.20, you will get an answer of 95.45, and this is milligrams of ibuprofen. So notice the one unit that didn't cancel out, the milligrams of ibuprofen here, is what our answer is. Those units stay. So if it is 95.45 milligrams of ibuprofen that this child needs, then how much of the liquid do we suck out of the bottle? And since we know there are 100 milligrams of ibuprofen in every 5 milliliters in this solution, we'll just do a simple multiplication like this, and I write milligrams of ibuprofen on the bottom, so it will cancel. And now when I take 95.45 and I multiply by 5 and then divide by 100, I will have my answer of how many milliliters. So 4.77. And that's 4.77 milliliters of the solution that I need to suck out of the bottle. Now, hopefully my syringe has units of milliliters, which most of them do. So that means we need to suck out 4.77 milliliters of this solution to administer to a child who is 21 pounds, so that he'll get the right amount of ibuprofen that he needs according to what the bottle has set out for us. Now, one other thing I want you to notice here, we came out with 4.77 milliliters. This is a volume, and we're relating a mass or a weight here to this volume. So we needed a conversion, which was the one we used, 10 milligrams for every kilogram. Okay, So this wraps up today's problem of the day. Hope to see you back for more.